Okay, this is a threesome problem that I actually did earlier, but my phone battery died and I didn't realize. I just continued working on this problem. So I'm going to do it again. Okay. This is Leetcode 15, and this is a medium difficulty level question. So given an input array here, we'll call it nums. Yeah, I don't know why. Oh, that's an S. Okay. We'll call this nums, and what we're trying to do is return all pairs, or not pairs, pairs would be two elements. So all triplets that sum up to a target, and then in this case the target would be 0. But this should kind of work with any target, I believe. Yeah. So this is the array that we're given, and what we're trying to return is, I'll write this. So we're returning an array that has x elements, and each element would be a triplet, right? So this one, -1, 0, and 1 sum up to 0. So that would be included in our answer array. And then -1, -1, and 2 would also sum up to 0. So we would return that triplet. And then these are the only two triplets in this example, unless I'm forgetting something or not seeing it. Yeah, I'm pretty sure that's it. So we would return this array of 2 elements, and those 2 elements are arrays of 3 integer elements. So what we need to do first is we need to sort this number array, and then take advantage of the sorted properties of this array. So we sort it. This is an n log n time, but the end result's going to be something in O of n squared runtime. So you sort this, and you're going to be given this array, where the array is going to change into this. So 1, 2, right? And then the basic idea is to iterate through this array. Like this could be I, and then we'll set a left index, and then a right index. And the triplets of sorry. And the triplets of here is -4, -1, and 2, which is -5 plus 2, which is -3, which is not equal to our target, which is going to be 0, like I mentioned before. So since -3 is less than our target, we need to move that number up. So it needs to be closer to 0, right? And the only way to do that here is to move I or L, but I think it's pretty obvious here. We want to keep our R, because that's our highest element right now, and then just increment L until we get to R. Or if we find a triplet that sums up to our target, then we can append it into our results array. So here we would move L to this, -1, same thing, because it's -1, move it again. Now we have -2. Now we have just 1, which is still not equal to 0. So we go to the next iteration. So this is at I, this is at L, this is at R. -1, -1, 2 does sum up to 0. So we add it into our results array, which we already did. Just looking at it. And then we would move both L and R if we haven't finished looking through all the elements. So just that looking through process is going to be O of n squared, which is better than, I think, when you first see this, like if you're a beginner and you first see this problem, you'd probably think of a brute force solution, which would be O of n cubed solution. You just do 3 for loops and check I, j, k, 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 etc. I hope you saw where my finger was. But yeah, this is the general idea, and the runtime for this is just going to be O of n log n for the sort, plus O of n squared. And then you can drop this, so it would just be O of n squared. So yeah, now we can convert them to actual running Python code, which isn't too hard. There's just for this variation of the problem, there's just a few things that you have to consider because of potential like duplicates. We don't want any duplicates here. So if we had like another -1 here, we don't want to have -1, -1, 2, -1, -1, 2. So we just want to have it in there once. So there's like just an easy conditional that we can use to check for that. So yeah, let's get started. So define, it's called 3sum. And then we have a numbers array. And then we have a result that we're storing our answer in. And then we want to sort it, like I said before. In Python, it's just nums.sort. And log in. And yeah, and then let's now iterate. So we'll go for I in range of length of nums. Range of length of nums -1. And then L R is equal to I plus 1. R is equal to the length of nums minus 1. And then, so this is where we're checking for duplicates. So while I is equal to 0 or nums I plus 1 is greater than the number before it. We could do like nums I is less than I plus 1. This is the only cases that we would consider our triplets. So here, so now we have this, right? We have I initially at index 0, L is I plus 1, which is index 1, and then R is at index 5. Right, so let's crouch down here. So if, I'm just going to shorthand nums for n. So if n of I plus n of L plus n of R is equal to our target, which in our case is just 0. Oh, sorry. This should be, I screwed up here. So this should be, yeah. Yeah, okay, I can write it like this. Shouldn't change anything. So this is not a while loop. This is if I is equal to 0, yikes. If I is equal to 0, alright, we forgot our while loop. Well, L is less than R if n of I plus n of L plus n of R is equal to our target, then what do? We add that triplet into our results, right? So let's do result.append n of I, n of L, n of R. And this is handling duplicates as well, because it's always going to be in sorted order. So otherwise, so an elif n of I plus n of L plus n of R is less than 0, then what do we do here, right? So in this case, we have -3 less than 0, right? So what did we say we wanted to do? We wanted to increment L over by 1, right? And then we're still within this while loop. So we can do L plus equals 1, that's all. And then else, and I missed a step again, jeez. Resident append, we're not done here, because we need to get all pairs, so we need to do this. So within here, I'm just going to write L plus equals 1, R minus equals 1. Right, so here, else, L plus equals 1, R minus equal 1, because we need to move L over and then right over. No, you do not do that here, because this would be just a greater than the target. So here we would just do R. It's late in the day. I've been working a lot today, so my brain is fried. So R minus equals 1 here. And then at the end, we just return results. Here, we can go over the runtimes again here of n log n, right? This, looping through n, nums, it's a factor of O of n, right? Easy, do n times. And then it's constant time, we're just updating L and R. If I is equal to that, or you're comparing two numbers, constant time. This should be out here, or I guess another if statement, it's fine. So this while loop, while L is less than R, L is going to be here and here, so it's just going to be constantly going through all the elements of n. So you can think of it as another factor of O of n. And since we're within this for loop, this, and these are just comparisons, which is constant time operation. So within this for loop, we're doing another factor of O of n, which gives us O of n squared for this whole bracket. And here, this is supposed to be right here. O of n times O of n is O of n squared, right? So this is where we get the, right here, O of n log n plus O of n squared. This pretty much acts like a constant, so we could rule that out. The runtime is O of n squared, which is the fastest time you can do this problem. And the results is going to be an array of x pairs. So you could say that's this O of, let's see how many pairs we have. I guess you could consider it O of n, because it'll never get greater than n pairs. Yeah, because we're not counting duplicates. So yeah, what else? Oh yeah, let's actually run through it. Yeah, so nums.sort. This is nums. This is nums.sort. And then yeah, let's do it. So I will write it here. I equals 0, L is equal to 1, R is equal to 5. I'll move on over. That's an ugly 5. R is equal to 5. Right. And look at this over here. If I is equal to 0, which it is, we go to this while loop. L is less than R. Does the sum of these triplets equal to 0? No, it does not. So it's less than 0. So we move L over by 1. Yeah, I'm not gonna update these very often. Move L. Still the same. Move L. So you can actually even use like a while loop within. It's like here, like while this is less than 0, just continue moving through, but it's the same runtime. You go here, L less than R still. You move it over. Breaks out of the while loop. While L is less than R. Yeah. Yeah, that's right. Okay, so we break out. R is going to stay the same. And then index I is at here now. That's at at 1, L's at 2 are still at 5. So now what? IL. I is not equal to 0, and nums of I plus 1, which is this. Yeah, so I guess I should be updating L afterwards, but it's okay here. It's just a little bit harder to read. So I plus 1, which is negative 1, is not greater than I. So we skip this comparison because we don't want to consider the duplicates. Wait a minute. I is equal to 0 or nums of I plus 1 is greater than or equal to nums of I. This should be... That's alright. We should check from or nums of I is greater than nums of I minus 1. Right? So when we're here, negative 1 is greater than 4, so we continue with the iteration. Yeah, I think that'll work. Let's try that out. So while L is less than R, which it is, if NILR is equal to 0, which this pair is, we will append this pair into our results, and then move L over, and then R over. Right? So we did that, and we have this pair inside our results array. And then we iterate, well, L is still less than R, so we find the next pair, negative 1, 0, and 1. So we add that results into our results array. Yes, yeah, that works. So now that we finished with that I, we're at now I is equal to negative 1. And we go here, we update L and R. L is 3, R is 5. Yeah, I is not 0. Nums at I, negative 1, is not greater than nums at I minus 1, which is just the previous one that we did. So we already added this one in. So if we were to count this again, we would get this triplet again, which we already put inside there. So skip this iteration and go I here, L here, R here. And actually, I guess you could just break out earlier. If you see that you're at the end of the array. So I guess you could do something, you could do a check like if, so this is, length of the array here is 6, right? So length is 6. And then we are looking for a triplet, which means 3. So if like, you could do, if I is here is 0 to 3, 3. If I plus 3 is equal to the length of array, no, here is fine. You would want to do this. So if I length of, oh yeah, I guess you could do length of array plus 1, then you can just break. Because that would mean I is at our index 1, and there's no triplets here to check. Right, that makes sense, right? 5 plus 3, which is 8. No, I'm doing basic math wrong, which is okay. The length of array is 6. Right, so if we're at 4, we don't do 3. No, if we're at 3, we don't break, but if we're at 4, we break. So if I is equal to length of array minus 2, then you could break. Yeah, because we break here at index 4. At the array, yeah. Yeah, I mean, I don't know why I'm going off on this tangent. It doesn't matter. It's going to be the same runtime regardless. It just might save a few milliseconds, but yeah, it's not necessary. But yeah, that's the solution.